Basically, a typical cylinder will consist of these parts, whereas the one there will be a piston, which is a major one, and the other one there will be a piston rod, which is a major one. So, due to this pneumatic systems, when which fluid is being used as a working one, this cylinder is been predominantly concentrates majorly on washers and so this consists of an end cap, bearings, the barrels, piston, the seals, and the piston rod, bearings, bushers, and scraper ring and connecting rod seals. These are all the major constituents of any cylinder, irrespective of the type of or the principle of working of any cylinder. These are have been very much required. A cylinder barrel is nothing but a cylindrical shape, a surface. What you can see it here, the outer surface. This is nothing but a cylinder in which inside this cylinder we will have the rest of the parts. The end of the cap that will be on both the sides actually. One we call it as a top dead center and the other one is a bottom dead centers. And both the caps we call it as an end caps. TDC is the topmost dead center and the BDC is the bottommost dead center. So the bearing caps will also be there in order to facilitate this piston and as well as this connecting rod for the easy movement. The meanwhile, in order to check the leakages which is possible during this pneumatic systems, a proper sealings and the bushers are used. Bushers even in our mixers and we will have it that bushers in order to provide two aspects. The bushers will perform two functions. One is it prevents the leakages, and the second one is it will absorb the shocks. It will absorb the shocks, and the third one is it will also facilitate a proper lubrication effect for the moving parts. Now, my dear friends, this is the piston rod which will be moving inside and outside, extension and retraction. During this, a bush will always be placed over here. A bush will be always placed over here. So due to this movement, whether it may be this bushes, whether it may be a rotary motion or it may be a linear motion, whatever the vibrations or the shocks that is being generated, that will be absorbed by these bushes. In most of the cases, this bush will be made up of different materials, starting from copper material to this rubber materials. So based on the nature of applications and laws and principle, different bushes have been used. The air motors, first of all, a motor is a one which produces the mechanical movements into the pneumatic movements. This divides with possibility of continuous motion, which are known as the pneumatic motors. That is the devices which transfer pneumatic energy into mechanical energy. That is the fluid energy that is being generated by using a gaseous fluid to into mechanical energy. That is what we call it as a pneumatic motor. The pneumatic motors with the unlimited angle of rotation has become one of the most widely used working element operating on compressed air. Basically what happens, any motors will have a restricted movement. Even if you take your palm, a palm of our hand will be a restricted movement. It cannot rotate 100% or 360 degrees. It will not rotate. Maybe around 30 degrees to the left and 30 degrees to the right. That is what our palm is restricted being. When you take our shoulder, it can rotate 360 degrees. So, a pneumatic motors with a maximum angle of rotation. That means limitations without a limitations if we has an angle of rotation that is been very popular and useful in the working elements. Pneumatic motors are categorized according to the design. Piston motors, sliding wheel motors, gear motors and turbines. These are the category of air motors. This is a one example wherein the left side one, what you can see it is here is a air motors with a five piston cylinder arrangements. All these five all these five pistons connecting rod is been coupled to the single point. Is it clear? So this is a graphical representation over here. Air motors, I guess I have some videos. I will show you, which gives you a clear picture. No, I don't have. I just shall will show you in the next class how these things will work out. No, this is a pneumatic grippers. Grippers, as I was just talking about yesterday, grippers are nothing but an end effectors. I guess I have told you. One thing familiar is this: three jaw. Three jaw chuck or the four jaw chuck, which will be very effective in holding the tools. Clear? Now, this is a vacuum generators. Vacuum generators are the one which sucks the air in a system and creates a vacuum. Handling with suction cups is generally a simple, a low cost and reliable solution. Suction cups allows the handling of different workpieces with a weight ranging from a few grams right up to several hundreds of kilograms. Okay. They come in a wide variety of different shapes such as universal, flat and bellows suction cups. These are all the different examples for this vacuum cups. Vacuum cups, it is something like a half ball. If you take a cricket ball, if you cut it exactly in the middle, okay. So if you keep it on some material and create a vacuum, then it will have a higher gripper than our mechanical grippers. So that is what it meant to be. This is a what you can see it here. This is something like a cup like structure, and above this there will be a one holder which facilitates for you to hold it. Once if you create a suction over here, whatever the physical contact material which is in touch with this will have a firm grip or holding for that. Is it clear? So these are all the graphical representation for a single acting cylinder. This is just a repetition even in your hydraulic systems, single acting cylinder and spring return. Now this shape will tells us a spring return single acting cylinder, and this is a double acting cylinder. This is also a double acting cylinder with double ended piston. Okay, now this is a double acting cylinder with non adjustable cushioning. Cushioning will be there. Okay, and single adjustable, this is without cushioning actually. This is single adjustable with cushioning, and this is double adjusting with cushioning. These are all the different graphical representation. Okay, now let me talk about pneumatic valves. A valve is a device which is used to control output of the circuit. Output of the circuit, whether it can be a hydraulic or it can be a pneumatic also. Only thing is, it will control the flow, it will control the pressure, it will also control the leakages. So the purpose of using valves are very much different. Say for example, the valves are nothing but like a taps which we use it in our domestic day to day, even in our bathroom to the kitchens. It is also a type of a valve only. What are its uses? It holds the pressure, it controls the pressure, it allows the fluid to flow in a particular direction, and it will also allow the leakage to be under control. Okay, the main purpose of valve in pneumatic system or a hydraulic circuit is to control the final output. Valves are divided into number of groups according to what they control. Okay, the classification based on the function, they have been classified into directional control valve, flow control valve, and the pressure control valve. That is what we popularly call it as DCV, FCV, and PCV. DCV stands for directional control valve. As I just told you, if the valves are used to control, say for example, even in your farm fields ಅಲ್ಲಿ there will be a major pipe, and that pipe will be connected to a number of branches. In particularly, if you want the fluid to flow in any one particular direction, then in such kind of applications, direction control valve will be used. FCV is something like a taps, flow controller. When you want more discharge, you will open the tap completely. When you want a minimum amount of discharge, then you will close it and open it to a very small amount. So that is what we call it as a flow control valve as well as the directional control valve. The pressure control valve is obviously which controls the pressure of the fluid. Okay, next one is a design. Based on the design, the valves are being classified into spool valve and poppet valve. I will come to this spool and poppet type of valve when I talk about the principle and construction of these two types of valves. The method of actuation, how we actuate this, manual actuation or a mechanical actuation or a pneumatic actuation or electric actuation. Now, my dear friends, manual actuation is something you control the flow, you control the valve manually. Maybe every day, ಮನೆಗೆ ನೀರು ಬಿಡೋರು ಒಬ್ರು ಬರ್ತಾ ಇರ್ತಾರೆ ನೋಡಿ. Have a one small long uh, a lever like thing which he will put it and he will rotate it so that the valve will gets open and the water will start flowing it. So that is what we call it as a manual. Mechanical means even if you have seen it as uh, sprinkler irrigation, where there will be a small like a butterfly valve will be there which controls the flow of the fluid. That is what we call it as a mechanical type. And the pneumatic is the one where pneumatic systems are being used in order to control the fluid. And then the electrical one. Okay. Now, based on the mounting angle, it is a manifold, inline, and a subplate. Three different types of classifications are there for this mounting angle based on the mounting angle. And the last one is an application based. Whether you want to control the speed, then the speed control applications will be there. Signal processing will be there, and proportional valves will also be there. Okay. Next one is a functional classification of valves. Most commonly used valves are direction control valves, non-return valve. Non-return valve. Can you please somebody tell me where do we use this non-return valves? Non-return valves. Where do we use it?
ಇದ್ರಾಗ ಸರ್
Where?
ಮನಿ ಮೋಟರ್ ಹಚ್ಚಿರ್ತೇವಲ್ಲ ಸರ್,
Ah.
ಅದರಲ್ಲಿ ಒಂದೇ ಸೈಡ್ ನೀರ್ ಬರ್ಬೇಕು, ಇನ್ನೊಂದ್ ಸೈಡ್ ನೀರ್ ಬರಬಾರ್ದು ಅಂತ.
Wonderful. It is correct. It is correct. Maybe in the sump. Correct. Am I right, Fernandez? In the sump in the ನೀರು ಎತ್ಕೋಬೇಕಾದ್ರೆ ಆ ಸಂಪ್ ಎಂಡಿಗೆ ಪೈಪಲ್ಲಿ ಏನ್ ಮಾಡಿರ್ತೀವಿ, ವಿ ವಿಲ್ ಕೀಪ್ ಎ ನಾನ್ ರಿಟರ್ನ್ ವಾಲ್ವ್ ಅಂತ ಕರಿತೀವಿ. ಆರ್ ಒನ್ ವೇ ವಾಲ್ವ್ ಅಂತ ಬಿಟ್ಟು ವಿ ಆಲ್ಸೋ ಕಾಲ್ ಇಟ್ as a one way valve or non-return valve. That means once if you start sucking the water from the sink or a syntax, I'm so sorry, from the sump, the water will start flowing. Once you switch off the motor, the water will stop there itself. No, this is a majorly important in order to avoid what? Cavitation. In order to avoid the cavitation, non-return valves plays a vital role. Without this non-return valves, every day you have to fill it manually and you should start the pumps. That should not happen. So non-return valves will plays a major role in avoiding the cavitation. In other words, it also extends the life of a pumps. So these are all the non-return valves, and then the pressure control valves. Obviously, then the last one will be a flow control valve. Directional control valves. The control valve symbols is this. Okay. If you have a two positions, that means on and off position is there. Then two. I guess I just discussed it in the first module, second module while I was talking about circuit diagrams. Two positions, one box and two box will. If there are three positions will be there. Okay, the basic symbol of a control valve is a square. Two or more squares are used, each square representing the switching position provided by the valve. I have already told you in certain cases, now you here, this symbol will indicate the inlet and outlet. That is number of ports I am talking about. There are two ports, correct? So this line will indicate two ports, and this boxes will tell you the number of positions. Okay. Flow. Flow is from bottom to the top. This is what graphical represent. Lines in the boxes are used to show flow path with arrows indicating direction of the flow. So this arrow mark is indicating that from bottom to top it is going. Suppose if this line is not there, if I have a two parallel lines like this, that means there is no flow. There is no flow, or it may also we call it as a there is a shut off. That means it is a off position. Is that clear? This is a representation. So the pipe connections that is an inlet and outlet ports to the valve are indicated by lines drawn on outside of the box and right angle to the horizontal line. Okay. The first position from the left indicates that the rest initial or neutral position when the valve is not actuated. The first position, that means if you have a three, this one, this is a one. The first rectangular box or a square box which will indicate the first position of the valve. Second one will always indicates a neutral position. And this, the third one will always indicates the third position. Now, this is what he says. The first position from the left indicates the rest position irbodu ಅಥವಾ initial position or the neutral position when the valve is not actuated. The second position or a square from the left indicates actuated position. That's it. See here, my dear friend, this is one position, single position, and four ports are there. One, two, three, four ports are there. Now this is two position and four ports. This is three position and four ports are there. Any doubts? Any doubts here? Next. Okay, fine then. Thank you. The port and position tables. The ports of the valve are shown on the outside of the box. This is what I was just talking about. Ports. Ports are always shown on the outside of the boxes. Is that clear? These are labeled by a number of or letters. You can number it as a 1, 2, 3, 4, or you can also number it as A, B, C, D. Usually, I will go with the letters so that gives us a clear picture. Say for example, if you are sending it is coming from the pump, then I will use it as a pump. If it is going back to the reservoir, I will use it as a R. If it is going to the cylinder position, I will note it as A. If it is going to the cylinder position B, then I will note it as B. Okay. For this purpose, some standard letters or numbers with symbols are used, which are shown in the following table. This is what? Pressure port, this is P. Working port is A. Working port means, as I have already discussed you, my dear friends, when you have a cylinder, in few occasions, if you want to lift the weight, the fluid is being passed at the bottom of the cylinder. When you want to retract or when you want to lower down the load, then the fluid will be supplied to the top of the piston or topmost position of the cylinder. Is that clear? So this is what we call it as a pressure port, which is indicated by P, or 1. This is called as a supply port. Working port is a. Number of systems which will be 2. This is 3 bar 2. That is 3 positions and 2 ports. 3 positions and direction control valves. Working ports are notated as AB. Exhaust port, I was just talking about. Exhaust port, or we can also call it as a reservoir port, which is denoted by R. Okay, exhaust ports RES, it can be used. Pilot port, maybe you may not come across with this pilot ports, but still it will be there. Pilot ports is nothing but it's something like a bypass. ಪ್ರತಿಯೊಂದು ಊರಿಗೂ ಒಂದು ರೋಡ್ ಇರುತ್ತೆ, ಕರೆಕ್ಟ್? ಇಫ್ ಯು ವಾಂಟ್ ಟು if you don't want to go to that place and you want to go to the next one, then there will be a bypass. So that is what we call it as a pilot port. Okay. Commonly used direction control valves. What are the commonly used direction control? DC valves is used to control or to change the direction or to start or stop of the fluid flow only on the receipt of any signal, which may be mechanical or electrical or maybe a fluid pressure pilot signals. Direction control valves are only used to change the direction or start or stop. That's it. DC valves are described by number of ports and number of positions. N bar N wave valves. That is N maybe 1, 2, 3. This can be M bar N upper. Sorry. Commonly used direction control valves are two position, two ports, two position, three. This is actually three ports, two position, four ports and two position, five ports and two positions. One input, three ports andre yavirutte, one input and one output and one exhaust. Four ports is two outputs. Five will be two exhaust and two outputs and one input. This is an important one. So this is what we call it as a ports. Number of ports will be there. Okay. Ports and position ways. Now beautiful actually. Now 2 bar 2 2 bar 2. Now there is a and two ports are there. Now in the first one, leftmost is an initial one or a shut off one. There is no flow. In the second position, the fluid is flowing from first port to the second port. Similarly, it is a 3 bar 2. That means three ports are there. Three ports. Here, from the first port, it is going to the topwards, and the third port is closed. Is it clear? One in the two ಹೋಗ್ತಾ ಇದೆ and the third port is closed. Now in the second position, what is happening? First port is closed and from the second port it is going to the third port. Now three ports ಇದ್ದಾಗ ಏನಿರುತ್ತೆ? One input, one output and one exhaust. Now this is the input, this is the input, this is the output and this is the exhaust. From input to the output it is going. In the second position, from the output to the exhaust it is going and the input is closed. Is it clear? Now this is normally open. This is one. This can be 3 bar 2, can also be like this. This is the 4 bar 2. From port 1 it is going to the port 4 and from port 2 it is going to the port 3. Now in the second position it is reverse. From inlet port it is going to the output port 2. From output port 4 it is going to the exhaust. 4 ports ಇದ್ದಾಗ ಏನೇನಿರುತ್ತೆ my dear friends? 4 ports ಇದ್ದಾಗ one input and one exhaust and two outputs will be there. Now here 4 and 2 are two outputs. 1 and 3 are, one is an input and 3 is an exhaust. Getting my point? Now similarly 5 bar 2. In case of 5 bar 2 we will have two exhaust and two outputs and only one in input. So this is the position what you can expect. 5 bar 3 is a very essential one. What you can see it here. Three positions are there. Okay. 2 bar 2 way valve. See, this is what I have elaborated over here. This is the pressure port and this is the output port. It is closed in the second port. This is 2 by 2 way valves normally. This is 3 bar 2 valves. Three ports are there and initially no flow from 1 to 2, but flow from 2 to 3, switch to flow from 1 to 2 and 3 is closed. Here 3 is closed. See, this is what. The same thing I have explained. Now this has been elaborated. That's it. Is it clear? Same thing 5 bar 2 and this is a non-return valve. Non-return valve ಬಂದರೆ it has given a very beautiful see here. In the non-return valve, the fluid will be coming because you are creating no at this section. Can you see the cursor? Can you see the cursor, Fernandez?
Yes, sir.
Here you are just creating a suction. Once the suction has been created, this will be pulled backwards. This will be pulled backwards. Then the fluid from the sump or the source, it will be flowing here like this. Once you switch off your pump, what happens? Due to the spring action, it will comes back and closes it. Then whatever the fluid which is been beyond this spring will be checked or it will be blocked above this. So there it will not have any way to go back to the source. So this is how the non-return valve certainly exists. And this is the graphical representation of this non-return valve. This is a pilot operated. Pilot operated means this is a major channel. It will be going like this. If you want to have another connection, so say for example drip irrigation, you might have seen it, my dear friends. Drip irrigation, if there are any people from agricultural background,
Yes,
you might have seen it. Drip irrigation, how this drip irrigation will be done? There will be a major one pipe will be there. For that pipe there will be a hundreds of pilot operated check valves will be there. Pilot operated means if there are 100 trees are there, there will be one major line for which there will be 100 pilot operated small pipes will be there. It will take the water and it will supply it. This is what we call it as a pilot operator. This is a two pressure valves. Pressure valves, this is like a tandem one. So there are two pistons and only one connecting rod is there. So it will be operating like this. It will go one like this, and the piston will move backwards, so that this will be closed. Whenever this piston, the first piston is on the leftmost position, it is an open position for the passage 1. When this first piston is on the leftmost position, this third piston will be a closed one. When this third piston moves to the rightmost position, then the way for the first piston will be closed one. See, this is the what. This is how it just operates and controls the pressure. This is a shuttle valve. Shuttle valve means whenever you want to block any passages, a ball like bearing or a ball will be used in order to close this. Now this is a passage is been closed over here, and whenever you want to close this, the fluid is coming from the port 1 from the from the right side, and it is going to the output to the second one. When you want to close this, the ball will occupy this place and it closes this position, and the fluid will be coming from this one, from the left position, and it just carries on. This kind of shuttle valves you can see it in a water filters, domestic water filters, Kent ಅವೆಲ್ಲ ಬರ್ತಾವಲ್ಲ, there you can see this shuttle valves, and this is the graphical representation of the shuttle valves. This is the flow control valves, simple one way flow control valve. This is a one way flow control valve, and this is a two way flow control valves, adjustable. Throttling valve means you can control the speed. Whenever, say for example, I was just talking about the air cavitation effect. Cavitation effects, which is majorly happens when you have air bubbles getting entrapped in the flow of the fluid. When you want to remove this entrapped air bubbles which is there in the water passage, you can use this throttling valve, where by using this screw you can allow the fluid to flow faster, and by rotating this or by closing this you can also check flow of the fluid. So this is the one. This is a realistic one, and this is a graphical represent. This is the graphical representation, and this is the animation one. By adjusting this screw, you can control the flow of the liquid. This is a one-way flow control valve, and there will be a two-way control valve. Will also be there. Pressure control valves. The function of the pressure valves is to influence the pressure in the overall pneumatic systems or in a part of the system. Are generally adjustable against spring compression. The symbols are distinguished according to the flowing text. Pressure regulating valves without relief port and with relief port, and sequence valves are the different one they have been used. This is a spring control valve, pressure control valves. Adjustable pressure regulating valve, non-relieving type. These are all the graphical representation. This may not be important for you people, but in order to have a view, I just have given this graphical representation. Okay, that ends your the third module. Okay, so the next we shall go for the fourth module, where we will have to uh, study about the logical gates, or I may go for